Welcome again. And my name is Peter Neumark. I worked in a number of places, including Prezi in recent years. And today I would like to talk to you about building microservices without going insane. Before we launch into this topic, it's good to agree on a definition of the term because it means so many things to so many different people. This one I happen to like quite a bit. Independent processes communicating with each other using network APIs. Nothing too fancy in there, right? And then this is the part where some of you guys are like, okay, just say it. But some of you guys are like, what's going on? So if you say that enough times, you start realizing that this isn't really all that terribly new. In fact, it might just be kind of a buzzword, a rebranding of something that we've known and feared for years and years. Something called distributed systems. It's a really scary font. But it's suitable for this technology because it's one of those dark segments of computer science where even the simplest things are terribly complicated. If you want to increment a counter, if you want to set messages in order, if you want to invalidate a cache, well, good luck. You can start writing this in PhD theses, big, thick volumes about how to do that correctly. It's notoriously difficult to do distributed systems programming correctly. It's similar to multi-threaded programming in this sense. And the reason is that concurrency is impossible to get right. Nobody's ever done it. Okay, that's not true, but it's pretty freaking difficult, right? So if you can avoid having to go down this rabbit hole, you should. Sometimes I have people who come to me and they're like, you know, I was thinking we could take our application and kind of move with the times and make it microservices. And I'm thinking, you know, don't do that to yourself, man. You got a nice monolithic web stack, you got money cloning, you got customers, you understand what's going on. Don't jump in and scare distributed stuff, you know, just for the heck of it. Now, granted, of course, there are legitimate reasons for going down the microservice path. For example, one of the legitimate reasons is separating the stateful and stateless parts of your system. If you want to scale a system, then having separate stateful and stateless parts is useful because they need to be scaled differently. Scaling stateless parts is really simple. You just plug in more machines and that's it. The stateful parts are hard. You keep them in one component, then everything is stateful and you can't really scale anything. So that's one reason, that's legit. Another one that's really important is evolving large applications. Put your hand up if you've ever written code in an application that's over 1 million lines. Doesn't matter what language. Okay, now keep your hand up if it's 1 million lines in Perl. Yeah, every program is a 1 line in Perl, right? No, but seriously, if you have a large complex application and you want to change the language, the frameworks, you want to do massive architectural changes, it's going to be really freaking difficult to do that unless you first decompose the application to small independent processes. And in the definition, the network APIs, of course, that's not really talking about what kind of network they communicate on. It's talking about these processes having separate memory spaces. That's why network APIs are so important. We don't assume that we can access the same memory. And the third reason that I think is a really good reason to kind of go towards this direction is that if you want to do DevOps, then there's two ways you can do it. One way is the CTO comes back from a conference Monday morning and says, guys, I saw the light and we're doing microservices and DevOps and we're kicking out all the ops people. And then guess what? The company goes out of business. Because when you have a monolithic web app that's huge, with lots of traffic, you're going to need people who know things like, how does DNS actually work? What happens when the kernel's process table fills up? How do we tune TCP parameters and things like that? Most developers, including myself, don't really have an intimate knowledge of these subjects. And when you're in the middle of an outage, you need somebody who does. But one way you can start going down this DevOps road is if you say, okay, let's start with a small, relatively simple stateless service. You wrote it, you run it, let's see what happens. And chances are good that if it's stateless, the engineers who wrote it are going to be able to operate it, and nice and slowly you can actually transition to full-on DevOps. So that's another good reason. But no matter what your reason is for going towards microservices, there will be a strong urge, it's like a siren's call, to build this most beautiful, perfect system ever known to mankind. And it's going to look like this. I love this painting. It's so beautiful. Not only is it artistically beautiful, it's also such a wonderfully perfect symbol of overambitious architectural projects. And software architecture really isn't that much different than civil engineering. I mean, you have this great vision, this great plan, you start building it, and there's the engineer guy somewhere down the corner thinking, man, this is almost done, it's so cool. And everybody else around here like, when can we move in? Like, the roof isn't there? It's gonna rain in? What is this even useful for? Like, is there a shopping center there? Can I, like, sleep in it or something? And usually, when you want to build something, you don't typically want a Tower of Babel unless you're writing a PhD thesis. Normally, you want to solve a problem. For example, maybe you want to build a bus stop. That's pretty simple, right? I mean, it's not a really complex structure. How good of a bus stop would that be? It's not a very good bus stop, is it? So if you know what your problem is and you can solve it, you can do a lot better with much less work, because you're not trying to build a perfect solution, the end of all solutions, and then you have something that actually works. And the key is just solve well-defined existing problems. Don't work on stuff that might be useful someday in the future. That's the Tower of Babel stuff. Like, this is going to be great, man. I know it. Yeah, I'm sure it will. But let's work on stuff that actually solves an existing problem we have, because that's the way we know that it's actually useful what we're doing. I was at Prezi during the years when we had our wonderful Prezi meets Microservices adventure. Great fun, lots of good stuff, lots of good stories. And most of the stories that I like telling as good stories are the ones we worked on stuff that actually hurt and we knew how to fix it. And most of the stories I'm like, well, I kind of have some regrets about that one. Those are the ones we would try to do something that's future-proof. And so we had the good, the bad, and the ugly. I'm only going to talk about the first two, okay? So one of the projects that was really good was kind of a drive towards database ownership. There was a point where we had a number of different pieces of code, sometimes in different languages, connecting the same MySQL database, doing stuff, and then we're like, well, we want to change the schema, but we can't, right? Because you have to update all those different services and scripts and everything at the same time. And you can't do that because you always have traffic. It's a hard problem until you say, okay, let's have one single interface for the database, one service to which all of these calls go, and if you want to change something behind the scenes, it's just that one service that needs to know about the new schema. We even moved databases between data centers this way. And it worked really well because we knew exactly what we needed to solve. We just needed to have a single point of entry for communicating with these databases. Another one that I like, and I think the guys who are actually in the room right now, is a really cool rate limiting technology that you can put in from any service, and you have, from an application's point of view, you have a fine grained control over which source or which service can request, the number of HTTP requests that you allow it to. And it's just super cool, and it was born out of the need to protect ourselves against other services in-house DOSing us. We're like, hey dude, I don't know if you noticed, but you're kind of killing my service, really cramping up my style. And then we're like, well, okay, maybe we should just try rate limiter and not have to have those conversations. So, very cool. And the final one that I want to kind of mention is faster CI. So this is, put your hand up if you've ever felt like, man, this build is taking too long. The rest of you are lying. So this is always a problem, that unit tests and acceptance tests and all this crap just takes too fucking long. It's never fast enough, and if it is right now, you don't have enough tests. That's the only reason it's fast enough right now. And we had the same thing, and this is a really big application. Python code, the compiler doesn't help at all because there is no compiler, right? So you need a lot of tests, and these tests take a long time to run. And so when we started taking services out, all of a sudden we're like, whoa, it doesn't take 90 minutes to do a deploy. It takes 3. That's really cool. So that was something that, again, a real need, a real problem, and then once we started going into microservices, it just magically got all better. And then some things didn't work out so well. So this is actually my fault, personally. When we started going down microservices, we realized that we need some kind of standard RPC protocol with some kind of wire format. Pretty sane stuff up to this point. This is where it gets insane. Let's make it binary, right? Because of course the biggest problem is efficient bandwidth usage. We don't care if developers take forever to understand what's going through the wire, and if they don't get the whole concept, and if they just hate it because you can't use curl to test things out. Let's do binary because that's cool. Well, that's what we did. It was a bad idea. It was my bad idea. I'm sorry. Coming out, binary wire formats anonymous. I'm sorry. Won't ever do it again. Okay, so that was kind of trying to future-proof something that there was no problem there to be solved. Another thing we did is we said, well, Prezi is kind of a Python shop, and what else would you say if 95% of the code is written in Python, at least the backend stuff? But we really want to go towards a JVM because all the cool kids like Twitter and Netflix, they're all in JVM. So we got to do the same thing. But it's kind of hard because all the code is in Python. Well, what we're going to do is we're going to do client libraries for our services, so it's really easy to interact with our APIs. And in addition to the Python ones, we had some Java ones as well. And it took an inordinate amount of time to get this right. It really, wrangle with Maven and hand-generating POM XML files, you name it, we did it. And we actually met it. It was a success. We built these client libraries, if I'm not mistaken, they're built to this very day, and nobody's ever used them, to my knowledge, ever. So, that's kind of wasteful. And the final example is a really cool technology that I'm not really sure why we didn't use, but we didn't use it. Twitter has this technology they call Zipkin, which is a distributed tracing mechanism, and an application around it, and it's very useful for kind of tackling problems with distributed systems, which of course microservices are. So this seems like a really good fit. And some of the really smart guys at Prezi actually did, I wasn't one of them, actually did an integration for Zipkin into Django, the framework we used at Prezi. Really cool stuff. I think it might even be open source, or it should be if it isn't, and then we never used it. It just didn't solve the problem. We evidently found it was important enough, so we never actually put that to use. And all of these examples, maybe the last one least so, but to a certain extent, all of them introduced complexity into the system. So things were harder to understand for new developers, hard to operate for people who are just trying to keep things going and reacting to an outage. The learning curve got steeper, and we got nothing in return, nothing out of these. And that's kind of what happens when you try to future-proof things. And I know what you're thinking now, because I'm a typical developer trying to do the same stuff. What you're thinking now, I assume, and tell me if I'm wrong, is that, okay, he didn't figure out what the future was, but I'm going to figure it out, and I'm going to get it right the first time. That's what I always think, anyway. And the reason I kind of tend to disagree with that is just the design space is so fucking huge. There are so many different problems we have to tackle, so many ways you can do it, and without having been there, done that, and burned yourself a couple of times, it's going to be really hard to have enough thought experiments to get it right the first time. And of course, it helps to read some blogs and look at what Martin Fowler has on his blog and all that stuff. But ultimately, it's really about what your business needs, what your value proposition is. Is latency a game changer for you or not? These things you're going to have to kind of go through and find out on your own. And in order to kind of show you what I mean, I want to go through a concrete example. Let's talk about service discovery, okay? Service discovery, if you have a monolithic application, is really easy. If you want to contact the log service, import log. Is that right? It's on your class path, or if you're crazy and you use OSGI, then you do some kind of OSGI magic, or if you use Python or PHP or whatever, somewhere that code's going to be located and it's going to be running. It's great. That's how simple it is. And then if you have a distributed system, you can kiss all that goodbye because you have a bunch of independent processes, but they're not independent in the sense that they function without each other, right? So they claim to make calls all the time, and they need to know where each other is, right? And that can get really tricky. It's really tricky to kind of bootstrap these things. So if I was starting a startup today, and I had little traffic and little time, I just put in a freaking config file like that. I mean, I don't have a lot of services. It's fast. The config file is loaded to memory. You just go straight to the service. There's no, no additional routing, nothing like that. It's super fast, super easy. It's really good until you reach the point where you have about 8 or 10 services. And then each time you add a new service, you change an IP, you have to go through 8 or 10 config files, and then you forget one, there's a typo somewhere, and all these things cause an outage. Wouldn't it be great at this point? Okay, it's not a two-man startup anymore. This is like a small company at this point. Wouldn't it be great if there was some sort of centralized way, some kind of highly available database that would somehow take a service name and give me IP addresses? That would just be the bomb. Well, there is, right? It's DNS. It's been around forever. I could just say logservice.api.company.com and boom. It's resolved an IP address and I can use it. It's great. It's dynamic. It's a well-known technology. Anybody with sandals and a beard knows how to use it. It's really cool. It does have some drawbacks. There is a little bit of overhead for DNS. Chances are that's not going to be an issue for you. And then local development is hard because the application reaches out to specific domains, and if you don't have that domain configured in your host file, or you don't have a local DNS running, or you need to call a service that calls a service or stuff like that, it's going to be hard to do locally, and chances are that will affect you. But it's still, a lot more flexible than the previous example. But if you start out with this and you don't know DNS, then you could spend a day writing that service, or you could spend a day learning about DNS. So it depends on what your skill set is. If you don't know about DNS, this is probably not the best way to start. It's probably better to start with the config file example. Now, for both of these, there's a small problem. DNS is very reliable, but once the domain name is resolved to an IP address, it goes to a single machine, and if that machine is out, or if that machine is overloaded, then the service can't be reached. So wouldn't it be awesome if you could somehow make this redundant and more reliable and all that? Well, there's technology for that too. It's called a load balancer. You just put the load balancer in front, and then boom, magic happens and everything is good, right? Almost. If you have a stateless application, then that's pretty much what happens. You just keep adding machines. You're on the cover of Slashdot, Hacker News, whatever, just keep adding those machines, and you're good. If you have something stateful, that's a different story. Then it's a lot trickier. You can do sticky sessions, so the same users always come to the same machine, but then you can't really scale, and if that machine dies and those users can't use the service, this is why previously I said it's a good reason to do microservices, to separate the stateful and stateless parts of your system, because they have very different scaling properties. But altogether, this is still pretty cool. There are some small drawbacks. First of all, the load balancer is a single point of failure. So if the load balancer dies, you're dead. Fortunately, typically, like for example, Amazon's ELB is highly available, so it's rare that those things go down, but it can happen. There is some latency because all the traffic passes through the load balancer. And what I mentioned earlier, either you have stateless services or you have sticky sessions. So you got to do something with this redundancy here. But it's still pretty good. And then you have a solution. It's kind of new. Of course, new, this rebranding kind of new. I mean, it's been around forever, but it's popular now to have a service directory somewhere. That's why it symbolizes the brain. All the services publish their availability, their URL or whatever, to the service directory. And then the different services pull this directory and have their own local copy of what service is running where. And then it just goes straight there. And every 2 or 3 seconds, they update their own local cache copy. And they just go straight to the service. Very cool. You can have several different nodes behind the service, so you get the same thing as you do with load balancing. It's even called client-side load balancing these days. I think that's a little confusing, but I understand why people use it. It sounds really cool. But this is what Twitter and Netflix use. And when Prezi started going down this microservices thing, we're like, well, that's what Twitter and Netflix use. That's what we gotta use too. It's obvious. And then we used it, and it sucked. Not because Netflix guys are stupid. They're really smart guys. But for Netflix, latency is a really big deal. That's what they're playing on. For Prezi, that's not really the case. I mean, it took like 5 minutes to set this thing up. Who cares if it loads another 2, right? So this is just not an issue. And we paid a lot of time trying to figure out how this works, learning how to operate it. This is new kind of critical technology. And another drawback is this needs client support. So good luck trying to use this with curl. If you're like earlier load balancer, curl is your friend. If you got this sort of setup, then you either write your own smart logic and whatever around it, or you're kind of left without tools. So that concludes our case study section. But this is just one particular area of microservice architecture. There's a couple other ones that are worth mentioning. How to do atomic transactions. How do you do local development? What about API versioning or RPC wireframe? My particular favorite subject. These are all things that you kind of have to know a little bit about this stuff to really come up with a good solution. And you have to know your business domain and your product's value proposition pretty well. And they all affect each other. That's the tricky thing. It's like one big ball of yarn. You start unwinding it, and they all touch each other. So I'd say service discovery is just the tip of the iceberg. There's a lot of stuff here. And then, as in my conclusion, I'd like to end with some happy thoughts. Because that list is pretty depressing. There's a lot of stuff on it you gotta think about. It's awful fun, but there's a lot of temptations to build the perfect thing right off the bat. Try to foolproof, future-proof stuff, and then work on stuff that isn't really useful. But there's a couple of things you can do to kind of stay on that straight and narrow path that leads to useful stuff. First of all, have a legitimate reason for going distributed, because there's a price to pay for it. Things are going to be more complicated. Anybody who tells you otherwise is kind of trying to sell something microservices related. Another thing, resist the urge to future-proof no matter what. Just hold your hand down, whatever, don't do it. Friends, don't let friends future-proof stuff. And finally, solve well-defined existing problems. If you're solving existing problems, CI is slow. I want to fix it. This bothers me. It's better now. Great. If you're solving a problem with rate limiting, you just had an outage, you know why. You don't want to ever have that outage again. Great. This is all good stuff. If you're spending weeks generating Java client libraries nobody's ever going to use, not so good stuff. Right? So existing well-defined problems, work on those. And for those of you who are on this road, it's fun. Have fun. It's great. And that concludes my presentation. And I'd like to thank this dude for helping put this in together. Thanks. That's it.